prototype, and that'll become abundantly clear why we're calling it a prototype. But we do plan to roll that out for all of the LIDAR data that we do have available, and I'll be going over that as well, what we do have, what's in process, and what we're hoping to get coverage for. So one thing I'll point out is that the prototype is actually of the Addison County LIDAR data, which has a resolution of 1.6 meters. The image you're seeing on the opening slide here is actually of Waterbury. It's a pre-release data set we got from the current data capture, and that's at 0.7 meters, so the resolution is quite a bit better. So I'm going to be going back and forth between the LIDAR for Addison, but also kind of showing you what's coming down the pike. All data collected from here on out is going to be of this higher resolution, which is very good news. So real quick, I could spend a lot of time on a lot of this, but I'm going to breeze over it all. The Vermont LIDAR Initiative is an initiative of the Enterprise Geospatial Consortium's LIDAR work group, what we're calling V-Team LIDAR. It's made up of a number of academic, state, public sector, and federal entities, and we're all basically coordinating to move the ball down the field to getting statewide LIDAR. And so we do a lot of different efforts in terms of working on proposals, some outreach, and working on the project planning aspect as well. So we're, coined the term the Vermont LIDAR Initiative, and we have some resources available. If you go to vcgi.vermont.gov/LIDAR, that's basically our central coordinating web page for all things LIDAR as far as it gets disseminated out from the Vermont LIDAR Initiative. And nationally, there is the higher level organization nationally is the National Digital Elevation Program, NDEP, and they have a 3-DEP program, which is what they're the instrument they're using to acquire data across the country, coordinating with states and regional entities to further data acquisition. We are currently going for a proposal under this program, which I'll talk a little bit about later, to try to finish up data for the rest of the state. So this is one of the topics I always struggle with. I know this is going to be review for some, but what is LIDAR? We have to talk about it very briefly, just so people can understand it, because it's a little mystifying in the beginning, but once you get it, it makes a lot of sense. So plane flies overhead, sends down these pulses of light, and the photons in those light pulses bounce off different features and come back. Some of them come back first return, some of them penetrate the canopy, some of them hit the ground, etc. And all that takes quite a while to categorize and quality control, quality check, which is why after they fly it, it usually takes 3, 4, sometimes 5 months to get the final data. So this is what you get. You get a point cloud. These points are classified with an attribute, and they also have an elevation. And from that, we derive all these different derivative data sets, like the primary, I'm calling them primary derivatives, are the digital elevation model and the digital surface model. And from that, we get all the secondary derivatives, which I'll go over shortly. So this has actually been this is part of the Missisquoi Basin 1.4 meter data. It's a farm up near the Canadian border. It's an old slide I had. This is the new data. This is Waterbury, the state complex. This is the 0.7 meter data. And if you look, you can just barely see a transmission line there. You can't really quite see the smokestack here that says the VSC on it. It's tiled in. It's a pretty smokestack if you've ever seen it. This was an output image I made from the program I have to manage the point cloud data. And this was the actual point cloud itself before I exported the image. You can quite readily see the smokestack here and the transmission line going here. So it's just amazing what you can see in the detail. And there are just so many different use cases you can apply this data to. It's what's so exciting about it. Again, more on what is LIDAR, how do we get the point cloud into usable data. What you're seeing up top here is the properties from a ArcGIS LAS data set. That's where we pull all the different points into this collective data set so that we can manage it from there. And again, these points have elevation values, and then they have these assigned classes. And there's a standard for that, of course. The ASPRS standard, you have all these different values assigned to those different points, and that allows us to manipulate it for deriving various data sets. So again, this is really just to help you visualize what happens when we get the point cloud here. We create a last data set. From that, we can say, give us the ground returns so that we can make this bare earth digital elevation model, and then give us the first returns down here to get the surface model, which will show the tops of trees or buildings, whatever is representing the surface of the earth, not the ground, but the actual surface, man-made and natural features. So once we have these two, again, these are the primary data sets, we can then make all these secondary derivative data sets, aspect, slope, contours, hillshade, and we can actually subtract the surface model from the bare earth model to get height of feature, known as the normalized digital surface model, which is pretty exciting. You can get height of features with the new data within 9.25 centimeters vertical accuracy, which is pretty phenomenal. Again, the federal program, the NDEP and 3DEP, they did a large national survey in 2012. And so with the results of that, they looked at the return on investment and costs and benefits of getting national LIDAR. And they came up with a summary that every 8 years would be a good balance between cost and use, and that the data, quote-unquote, data quality level, or QL, should be QL2, which has a vertical accuracy of 9.25 meters, 0.7 meter nominal point spacing, and supports 1-foot contours, which is great stuff. And this is just a listing of the different quality levels. The old USGS version 13 specification used to be QL3. We have 30% of the states covered by QL3 right now. The QL2, rather, as I mentioned, is what spec is going to be used for all future data acquisitions. There's actually a data acquisition going on right now, and that's QL2. And so it's going to support 1-foot contours and 0.7 meter resolution raster products. So this is what we have in Vermont right now. The gray areas are that QL3 I just mentioned. That's 30% of the state. We are never came up with a great acronym for this project area, but Grand Isle, Rutland County, the southwest corner of Addison County, Mad River Valley, and the Little River watershed, and this is the leftover piece of the Otter Creek subbasin, are all being acquired literally as we speak. And we're going to hear from both Lynn and of the USGS, Lynn Neifert and Jonathan Croft of eTrans, who are working, coordinating with the company acquiring that data. Then, just recently, I don't know how widely known this is, but this dark orange is the project that we just got funding for a couple months ago. So I'm hoping that's also being flown this fall. So that's really great coverage. That gets us up to 60%. This kind of a modeled area here, Essex County, is designated that way because, as I mentioned earlier, the results of the 3DEP program suggested anything, you want to get coverage every 8 years, and this is now 9 years old, about to be 10 years old. So we are throwing that under the category of needs data reacquisition. So these areas all here account for about 37% of the state, and that's what we're currently pursuing funding for. And other big news, I don't have the final extent for the data acquisition in New York for the Lake Champlain Basin that covers New York, but it sounds like it's going to do almost the entire Lake Champlain Basin in New York, which is roughly 2,600 square miles. So that's great news. That's currently in work and I think actively data being collected. But again, I'm going to let Lynn and or Jonathan speak to that. So good things are happening. We're really moving forward here with the data acquisition. And that brings us to, once we got this data, what can we do with it? We have data available for download on the VCGI Open Data Portal, and we're also have it available on that hard media brick product, And we're now moving to the next phase, which is we're making it into a imagery service. And let's just go look at it right now. Let's see that. There we go. Okay. So this is the address to this service, and we can access it in a number of different ways. We can add it to an ArcMap session. So if you have ArcMap installed on your desktop, if you just click on this, it's going to say, do you want to open with yes? We can show that later. For now, we can also go to Google Earth with it. And if we open up the ArcGIS Online, there's just a multiplicity of ways to access this data. We can also use our VCGI's Vermont Interactive Viewer. I can add it as against the backdrop of all these other services that are already here. And if we zoom in, notice you'll quickly, readily notice that the color ramp is funky. And this is why this is a prototype. We're having some problems with this. We're actually working with Esri as we speak to troubleshoot this. And they've acknowledged that, yes, there's something buggy about it, but they don't know what it is either. So we are working on it. And once we get it figured out, that's really going to be the linchpin to allow us to apply this to all the other existing QL3 data that we have for the Missisquoi Subbasin, Bennington County, Essex County, and well, we already have Addison County. And then as we get the additional data, and this is, we're going to be talking next year at this point for the QL2 data being worked on now, we'll integrate those into the service regime as well. But let's just take a little tour here, zoom in. This is not a cached version of the service, which renders much more quickly. Again, we were having problems with that, so we decided just to go with a straight non-cached service for demonstration purposes. And once we get our, once we get direction from Esri, we'll move forward with that. All right, so it does take a little while, but just wait till we get in nice and close, and you'll start to see the advantages of this high accuracy data. This is a quarry. I'm going to keep going, and you'll see that it takes a while to render. And again, keep in mind, this is the 1.6 meter data. It's quite impressive. And the other data from here forward is going to be 0.7 meter. So there's the you can see the imagery behind it, and this is the elevation image. Now you can almost pick out stone walls with this stuff. It's pretty great. There's a little this is a business down south of it. Look how you can see those rows just stand right out. And again, keep in mind, one of the other derivatives is that normalized digital surface model is going to give you height of feature. So you would actually be able to tell the area of these things and how high they are. Now, we are just providing the service. There are other, you can plug this into either your desktop, or if you're a web developer, you'll be able to pull this in to a website. And if you have the appropriate software and licensing and all that, you can create a website that will allow you to do geo-processing on this. So it'll be, you can work on it just as if you're analyzing it on your desktop in terms of calculating line of sight, volumetric calculations, aspect, kind of endless array of applications. Let me just show you real quick. This is a prototype, just to show you yet another use case for what you're going to be able to do with this type of stuff, is for a solar LIDAR. This is St. Albans City, and we were working with the Vermont Sustainable Jobs Fund to kind of extend the original Vermont Energy Atlas. We're going to go to the next evolution here and show just the solar LIDAR, so that people can make decisions about where they want to install solar, how much energy they can expect to generate from it. And again, this is 1.4 meter data, but just look at how you can see this building right here. Let me turn that off. You see this little dormer or something, but it's actually being reflected in a lower solar gain area, which I find pretty amazing that even shows up. All right, so that's the prototype, and let's see, we talked about the Q03.2. Other services that are available are accessible. It's more, well, there's a couple ways to access it. This is just showing all the quote-unquote REST endpoints, like more of a developer-oriented site. But if you go to our VCGI website and go under Data and Imagery and Web Services, this details out how you can access our existing image services and map services and geocoding services, and even details, even gives you a step-by-step of how to do it here. So you can just follow this right here, lays it all out for you, and that previous page shows all the different ones that are there. Now, if I wanted a quick map of the state of Vermont with roads and parcels and everything else, I don't actually know where it is right in here, but I do have it available on an already composed ArcGIS map document, which we can get to. But just wanted to demonstrate there are a multiplicity of services, map and image. And now you can represent LIDAR either as a map service or an image service. The difference being that a map is really just that. You don't have access to the actual values of the data, whereas in an image service, you do have access to those values. So you would be able to get the height and the elevation point value for a particular cell in that image service elevation model, or slope, or aspect, et cetera, et cetera. So this is our plan at the moment for the different services we are going to move forward with once we get through that prototype process. You'll notice that there are a number of map services, and we're using the LIDAR just to make a map. They render fairly quickly because they're just bringing the 0 to 255 values, just a color, just like a PNG file. It's just showing you a representation of the data cartographically, but you don't have access to the actual elevation values or aspect values or slope values in a map service. And we're going to do a hillshade in state plane, hillshade and web Mercator. And then we're going to add contours to one, both in state plane and web Mercator. And then when we get down to the image services, we're going to have it, we're not going to have it for every single primary and secondary LIDAR derivative, but we are going to have the DEMs, the DSMs, the NDSMs, aspects, and slopes. So that's most of them there. And there's also different types of services. There's one that require ArcGIS license, and there's others that are open source format web mapping services. Okay. And this is our implementation plan for all the different LIDAR-derived data sets. So we have the DEM. We're going to make that, basically everything's available on an external product. That's if you want to get all of it and then have it on a brick and attach it to your computer, there you go. You can have it all. For direct download, we're going to have pretty much everything. The problem with the last files is that they're very large, and unless you're really skilled and really want something unique, you don't really need them. They come with a lot of overhead in terms of knowledge required, licenses required, and data storage requirements. So we are not going to make those available for download. We have spoken with the NOAA Coastal Services Center, and they might be willing to host them, which would allow people to download them from there. They are doing that across the country, so we are just going to try to dovetail with that effort, and that's going to be sometime in 2015. That's not a top priority, to be honest. Now, map services, we're going to show, if you go back to that list here, we're going to show both DEM and DSMs as map services as well as image services, and ultimately, some of the other secondary derivatives like aspect and slope are also going to be published as services, and they're going to be integrated into the Vermont Interactive Map Viewer, which is that viewer that I used to show you right here. That's what we were looking at the data at. Okay. So there's our plan. This is how you can access it right now on the GeoData portal. And as I mentioned, there's product, class files, and services. So right, everybody is actually able to access this right now. If you follow this URL, you would be able to access these services, but they are not finished. Please don't use them in a website that you plan on, for your business uses just yet. It's fine to play around with it, and I actually would encourage people to play around with it. You're going to have to hold your nose on the color symbology, but the data is good. The values are there. And let me just point out that if you, speaking of values, if you add a hillshade, which is the prettier image, the only values you will get are going to be 0 to 255 hillshade values. Okay. If you want the actual elevation values, you're going to have to add the DEM. Just want to make that point clear. We also do have the cache version here, but it's funky. It'll draw faster, but the symbology is still off. So we're leaving all out there for people to access and play with, because we want your feedback. And now that we have it, we wanted to make it available. But it is preliminary, and we are working on it, and we're going to try to get the coverage for the data we do have as fast as we can. So getting a little bit very quickly into technical considerations. This is somewhat on the public side, and some of it's on our side. I'm just trying to give you an idea of like what we have to contend with when we're trying to make this service available. There's this issue of cache versus non-cache. The non-cache is slower, but you can change the projection. There's other properties you can manipulate, whereas you can't in a cache version. The cache version is faster, but it comes at the cost of being kind of hard-baked, so to speak, and you can't really manipulate it once you do cache it. Also for us, if we provide cache and non-cache, it takes up double the disk space and memory space, and that's all stuff that costs us money, and we have to go to bat with DII to get those expanded data services. And there's also the different configuration types. But I believe we are going to be serving up both the both the ArcGIS image service and the OGC WMS. So we're going to be doing this one here. Oops, sorry, I didn't mean to do that. I already showed you the solar potential modeling, and I think next we are going to benefit from Jarlath showing us some of the work that he's been doing up at the University of Vermont Spatial Analysis Lab, both with the height of tree canopies and also the high-resolution land cover that can be derived from LIDAR. And these data sets can also be made into a service, an imagery service. We don't currently have plans to do that, but just to explain the possibilities there, the opportunities there. So if Jarlath, you are ready.
Ready to go, Mike.
Hand that over, and you'll be seeing his screen here shortly. And then when he's done, we can send it back to me.
Sounds good. Thanks, Mike. I just wanted to quickly talk about derivative products that we're working on here at the Spatial Analysis Lab. We have some funding through an AmericaView grant to essentially follow the recent LIDAR acquisitions and begin to build out high-resolution land cover. So when we're talking high-resolution land cover, we're working on 7 easily identifiable classes. So sort of on the man-made feature side, we're talking buildings, roads/railroads, and then other paved. And on sort of the natural side, tree canopy, grass and shrub, bare soil, and water. What we do, our process for this is to take imagery, both the leaf-on NAPE that we have for the state and the leaf-off imagery. Take that, we bring in LIDAR data, such as the normalized digital surface model that Mike's mentioned before. So here we have a model that represents the height of features relative to the ground, so blue being the ground as we move out through the yellows and the oranges to the reds being clearly above ground features. So the combination of these two data sets with the spectral quality from the imagery and the 3D information from the LIDAR data. When we combine these and with our fancy techniques, this is an example of our high-resolution land cover data set. So these will be done at the resolution of either the LIDAR or the imagery, whichever is higher. So in cases where we have 7.7 meter LIDAR data, that's what it'll be done as. In areas where we just have sort of 1 meter NAPE and 1.6 meter LIDAR, that's what we'll go with. As you can see, very, very detailed, very accurate, and useful for a wide number of applications, whether it's computing impervious surfaces, estimating tree canopy, and so forth. We realize that people might be interested in non-top-down layers, so this is a top-down approach to mapping. So if you're out there and you have some additional funds that you might want to contribute to this project, so for example, just a representation of buildings for your county along with 3D attributes, let me know and we'd be happy to discuss that. In addition, we'll be working on developing canopy height models for all of these areas as well. So an example of the canopy height data that I'll show you here, what we do is we take the tree canopy that we identify in the land cover mapping. We then apply some segmentation algorithms. These segmentation algorithms sort of give a rough approximation of individual trees, but I'd never say that you should use it as a tree map. Our forests are extremely complex here in Vermont, close canopies, different species, trees under other trees, etc. But it gives you sort of some idea of the approximate location of the trees, and then from that we can compute the average canopy height. So by digging into the LIDAR point cloud, finding those points above ground, and then also the max canopy height. So we hope that these will be useful for a number of applications, from wildlife habitat mapping to biomass evaluation. Because once you have this, you can begin to plot out information to understand sort of the number of trees by canopy height segment. And then if we have any funds left over, we'll probably start looking into forest patch analysis. So this is something that we've been working on. We've developed this sort of 3 patch class, because obviously you can't, when you have high-resolution tree canopy, just look at the area of these patches, because you have tree canopy that's in these long, thin rows. It's often connected when viewed from above. So we have an algorithm that basically breaks it down into these 3 classes based on morphology, perimeter edge ratios, and so forth, and that can give you, for a given area, understanding of your large, medium, and small patches. And I don't want to take up a lot of time, but if folks are interested in collaborating on these projects, or you want more information, please let me know, and then I'll turn it back to you, Mike.
Okay, thank you, Jarlath. So pretty impressive use cases there, and really it's just the tip of the iceberg. There's so many different things we can do with this data: floodplain mapping, resiliency, transportation infrastructure, archaeology, solar, resources, town mapping, soils. I mean, the list just goes on and on and on. So it's a pretty exciting time that we find ourselves in, with more than half the state, almost 2/3 of it covered under contract, and we have a potential coming up. It's a proposal with, oh, I'm sorry, you guys can't see my screen. Thank you, Leslie. There we go. But with the proposal coming up, the U.S. Geological Survey has a broad agency announcement that we are actively pursuing. There's a pre-proposal. It's actually due this Friday, so we're all set with that. We're just throwing in our ideas and going to get feedback from USGS. But we are actually going to open up a dialogue with as many people as are interested to partner with this and build the broadest coalition possible. Of course, there's a financial element, but we're thinking stone soup on that one, and the more people that add in, regardless of the amount available, the better our proposal is going to be, and we're hoping to push up and over the top to get the remainder of the state done. So if you have any interest in that whatsoever, please contact either myself, Jonathan Croft, Lynn Neifert, I'm sorry, not Lynn, he can't participate in that, or David Broadsman here at VCGI, and we'll move forward on that. Also, we will be throwing out the invitation on the VGSIL here pretty shortly. So with that, I think we are going to move on to speak with Jonathan Croft at the Vermont Agency of Transportation, and after that, Lynn Neifert of the USGS can weigh in. We're just going to talk about, they're going to talk about the efforts going on within their organizations and how it relates to the overall picture of getting the statewide LIDAR acquisition under the Vermont LIDAR Initiative. So, Jonathan, if you're ready, Leslie, perhaps you could pass over control to Jonathan, and he can enlighten us on what's going on and with the current data acquisition happening literally as we speak.
Sure. There's actually some acquisition that's going on right now. They're trying to go back and collect the Rutland County area as well as the Mad River Valley. Some of that has been provided in pre-release, that they were able to capture it last year or this spring. But they're actually going back to collect some of the areas that they missed, and due to the weather conditions, they just weren't able to collect it. One of the considerations that we've got this year is there's a fairly hefty area, as you saw, the Rutland County, Chittenden County, Washington, Orleans, and Lamoille, essentially completing the Lake Champlain Basin. Those areas are all being collected, but we sort of are at the mercy of the weather, that we need some very specific conditions to be able to have the contractor go out and fly. And Lynn can speak to this a little bit more, but in general, we need to have days that are fairly clear, that they need to be fairly open and clear. The wind needs to be very low. We need to have no snow. There's also flooding is an issue, that we don't want to have any flooding. And for the Lake Champlain area, we want to also have a low water. So all these conditions have to sort of coalesce. And one other major consideration, too, is the leaf canopy, that we want to be able to look down through that canopy that has a laser pulse, be able to get to the bare earth so we can get a better modeling of the terrain. So the leaf off, no snow, clear conditions, low wind, because we want the plants to be able to stay on track, and then no flooding. It sort of creates a very limited number of days. And this year we have a large area. And Lynn can hopefully bring us up to date exactly where the contractor is, but I am aware that there were a handful of days this last week that the contractor was here on site. They also have some work that they're trying to clean up over in the White Mountains, so they're trying to get that before snow came with this nor'easter that came in over the weekend. So they were frantically collecting that, but they're also here in Vermont working on Rutland County.
Hey, Jonathan?
So, yes.
Can I just interrupt very briefly? Do you have anything on your screen that you wanted to show, or are you just doing?
I do not have anything on my screen.
Thanks. Sorry.
That's okay. So this is a fairly large area, a bit ambitious for this year. But one of the things, how it came about, is there's a whole collaboration of all kinds of multiple organizations that have all pulled together to be able to make this happen. Each of us has a bit of a special interest on what we want to collect. And VTrans, our interest is being able to utilize the LAS files in our engineering, being able to do preliminary engineering with a high-resolution terrain model saves us greatly on our site survey. We're able to actually derive a lot of information from the LIDAR data, and it actually moves our projects along a lot faster. Within the mapping section, we're actually able to use the bare earth terrain model to look at the roads that are obscured by a tree canopy, so we can actually improve the road centerline data by being able to see down through and see what that road alignment truly is. So there's a lot of benefit to the Agency of Transportation, and we've helped cost share in this last batch. This broad area announcement from the USGS to actually work on the 3DEP program sort of presents an interesting opportunity for everybody to be able to also contribute into the process. So I'm kind of putting out a little bit of a pitch that the more collaborators and the more funding that comes into it, the more potential for moving this project forward is. So it is a case where there is a cost share that the state would need to, or organizations within the state would need to come up with to be able to leverage the federal funds from the 12 organizations that are part of the 3DEP program. There we go. So Mike has actually put up a highway that's down in the Andover-Chester area where it's very obscured by the tree canopy, but when you have the LIDAR, it actually is very obvious that the road is there. You can see the stone walls on either side. So this is a great tool for us to be able to see these alignments. So we have an interest in it, so we're able to cost share. But I know that there are other organizations that could leverage this as well. Even small amounts put into the pool to create a collaborative effort, I think, is very worthwhile. So we'd like to see the remainder. There's a proposal that's been put in already, the pre-proposal, for the collection of all of the counties that bordered the Connecticut River, and also including Essex County that was collected some while ago. We'd like to get that recollected. So I guess that's what I had to say at the moment. I'm going to turn it back to you, Mike.
Thank you very much, Jonathan. So I'm just bouncing around here, showing some LIDAR mine candy in the background. I don't have the best software to manipulate the point cloud, but this is Global Mapper. It just gives you an idea. This is downtown Waterbury. This is Stowe Street. So you got Arvads over here, you got Cork over here, the Blackback, and the reservoir. Just showing you. You can even see, the power lines and telephone poles and everything. It's pretty amazing stuff. And you think about the data that you can derive from this and just use for myriad applications. It's really kind of mind-blowing. So let's push over the top and get the whole state. There's my plug. Now I think, Lynn, if you're ready, we could go for the federal overview and also the insight from USGS, who's overseeing the working with the states from the National Digital Innovation Program to acquire data for across the country eventually. And with that, if you're unmuted, Lynn, go ahead and take it away.
Can you hear me now?
Yep, sure can.
Okay, just verifying. The first thing I wanted to mention was the NEA survey, the National Enhanced Elevation Assessment, I believe it was called, and you mentioned that. And with that survey, a lot of the things came out that the QL2 became the standard. It's kind of an upgrade, and the reason you're seeing that is Vermont was done prior to that, parts of it that were QL3, which was kind of a standard. We just it kind of evolved. And then after the survey, they decided that QL2 would be the best value, where you would get the most for the money. So you have that line in time there where things all of a sudden have become much improved, I think. It's expensive. It's more expensive, I will say, but from experience, resolution's addictive. Once you've got high resolution, nobody ever wants to go backwards. So that's the reason for the split. As Mike said, and Jonathan gave you all the conditions, we have all this under contract. I believe there's 5 airplanes up here in Vermont right now. We have 100 square miles in New Hampshire in the White Mountains that they're trying to, I guess, kind of sneak in there. It's kind of being viewed as one project. And also there's, I believe, almost 2,000 square miles in New York that will be flown. And the entire Lake Champlain Basin is under contract. It's paid for. Jonathan went through all the weather conditions. I'm not going to repeat those. Trust me, there's nobody who hopes there's better weather than me. I've been through this for about 2 years now. I guess I don't have anything else, because I think everything's been pretty well explained up to this point, Mike, unless you have specific questions.
Okay, great. Thanks for that overview, Lynn. So what I've been just throwing around in the background is the 0.7 meter data, that quality level 2 that's being acquired as we speak for all the Lamoille, Winooski, and Orleans watershed subbasins in Orleans County, as well as Rutland County and Grand Isle. So it's going to be great to have that data. But again, this just shows you the here's the height of feature. So you would be able to get the height of trees. I'm going to pick the right one here. This will tell you, 24 meters, 10 meters. So pretty interesting. You can do. There's really no limit to the type of applications you can use this for. And I could spend hours doing that, but let's see if we can get back to the. I think I was just going to have at the end quick status for the available data sets, which are Addison, Bennington, Essex counties, and the Siskiyou Basin. We've made all the primary and secondary derivatives available on the Open Data Portal, and we've also got the 2-foot contours generated from that and integrated and available. We are now working. This is where we're talking about right now. We have a prototype of really just the DEM, and once we troubleshoot the issue with Esri, we're going to move forward to apply all of these data sets and make imagery services and base map services available that I outlined earlier. And then after that, we have much smaller extents. There were some floodplain projects done in Bennington and Rutland and Washington County, as well as the 2009 Barry Montpelier area, and a couple other different date stamps in Bennington, and the one post Irene done by VTrans to river corridors. So those occupy a much smaller area and are important, but I had to prioritize somewhere, so they fell into phase 3. And once those are made available on our various products and for download, we will go ahead and make services out of those as well. So that's kind of the overall picture moving forward. We talked about the proposal, stuff that's in work. Mentioned and Lynn reinforced that New York is fine data. When we have more information on that and an extent, I'll probably add that to the map, so that'll be useful to have. Here's a quick overview of some resources. I'll leave this page up in case you want to write down some of the links. You're certainly welcome to give me a buzz, email, call, whatever, stop by. All are viable options to talk about anything LIDAR related. And let's see, if there's one in particular. I would say probably the primary one is I've tried to coordinate everything through our LIDAR webpage, so vcgi.vermont.gov/LIDAR. And I guess the only other thing I can think of to say is that some of you are probably aware we're being integrated with the state. That's effective as of March 30th, and vcgi.org will no longer exist as of then, but we do not foresee any interruptions in the Vermont LIDAR initiative. I think it has wide appeal, and most people agree that it's not if we need this, but how, how the funding is going to happen for it. So I really don't see any interruption in the overall effort from our end on this at all. So I guess with that, unless there's questions, if people have questions, please feel free to hit me with them. And even if you think of them later, feel free to send me an email, and I'll follow up offline. And I believe Leslie probably have some closing statements. This is going to be archived on YouTube. It'll be available in the future if you want to reference it for other folks that weren't able to be here. I know a couple of people had other scheduled appointments. So with that, I'll thank you for your time. And,
so Mike, before you actually sign off, let's give people a chance to send in questions. Sometimes it takes a minute for them to type them in.
I guess I was just thinking I would hand over control to you for the questions, but sure.
Well, I am unlikely to be able to answer the questions. But yeah, take a look at what's there. I did answer one just because I actually knew the answer. But the second one's actually a comment from Craig. I don't know if you have access to the New York area, because he's just suggesting that if you have it and want to show it, you can. It's okay.
Oh, okay. Yes, I do. Let me think about where I put it. Yeah, it'll take me a second.
And maybe I will comment on the one thing I think I forgot to mention at the beginning is that, as I said, the recorded webinar will be posted at our YouTube page. If you go to our web page and go to the event archive area and click on webinars to see all the webinars listed, Mike's PowerPoint will be provided there. A link to his PowerPoint will be provided there. So if anybody's looking for that, I'll try to remember to also put it in the description for the posted video on YouTube. But if you're just at our website, you can access that in the event archive.
Oh, I also thought that I sort of already made a map out of it, so I could pull that up too. But let's see, either way, whichever one comes up first. I think it was most of Clinton County, which is it abuts Quebec and the lake. Yes, there it is in green. Now this has not been validated by anybody. I think it's an accurate representation of what Craig had sent me, but I didn't want to throw it up there until I'd verified it with him. But it's basically, as I understand it, Clinton County, then the sub-basins, which are part of the Lake Champlain Basin. So it's a huge area. I mean, it's humongous. So with their acquisition and with the current acquisition here in Rutland County, as Jonathan said, they flew the lake last fall for low lake level conditions, as well as the Grand Isle area. And they had also done this section of the Little River watershed, and a good chunk of the Mad River Valley. I believe the line is somewhat in here. So this stuff is, it's not going to be something we're going to post. I don't think it might be available on the data product, but if we posted it, then once it's available in the spring, we'd have to repost it again. We'll figure that one out. So yeah, so then we have the Otter Creek, and we're there. This is just the dark orange, the area that was just funded recently. So it's the Lamoille, Winooski. We already have the Missisquoi. We'll have the rest of the Missisquoi. We don't think we have data from Environment Canada there yet. I'll have to check on that. Their data sharing model is a little different, as everybody probably knows by now. So we're going to have almost the entire Lake Champlain Basin, or a vast majority of it. That's going to be a huge step forward for lake-related efforts.
There are a couple of questions in there now.
Sure. All right. See, I'm having a hard time seeing them because I can't expand my box to show them all.
There's a little icon right next to the X in the upper right corner. The one right next to it actually brings that whole thing out, so you can make it.
There you go. Okay.
Much easier.
So for existing data, when do we expect to have the web services up and running for the existing data? Well, I'm not blaming anybody. It's just really isn't Esri's core. They've acknowledged it's a bug. They've been able to reproduce it, but they haven't come up with a solution yet. So we're kind of in a wait mode. There's not really much else we can do because, especially creating cache web services, it's a lot of processing time and a lot of effort, and we don't want to do it if it's not correct, because then we would just have to redo it. So we're really just going to wait until we have a process detailed so that we can move forward with that. I know it's kind of maddening because you want to use this yesterday, but at least you do have the option of downloading it and storing it locally on your either your desktop or on your LAN. And I'm afraid that's the best we can do. We really can't move forward until we have a clear technical solution to it. There's really no way around that. The question is, will you be able to differentiate between tilled soils and hayfields on bare earth and ag landscapes? Well, I don't know. We'll have to ask. Oh, this is a question for you, Jarlath. Sorry. Jarlath, will you be able to differentiate between tilled soils and hayfields on bare earth and ag landscapes?
So that's gonna really depend on when the LIDAR was acquired, right? But typically for very, very fine scale features like that, in some cases you may notice some subtle differences, but those differences are going to have to be at least typically in the 10 to 20 centimeter range. So although the accuracy for LIDAR is below 10 centimeters, remember when they're doing that bare earth filtering, they're often getting rid of a lot of the noise in there, and sometimes those small variations are considered noise. So it's going to vary a lot by what the contractor's done and then how much you're seeing in terms of those till, and if the LIDAR was acquired at the right time that you're actually seeing those things. There's a lot of other stuff you can have in there. Vegetation that's current in the fields, corn stubble, all these things that can really complicate matters.
I'll add to that.
It's difficult to do, yeah. It's difficult to do, but maybe possible in certain cases.
The only surrogate I can think of, and I only bring this up because somebody asked me the other day, can we identify round bales from the LIDAR? And I'm like, well, kind of depends. As I drive around, I see them stacked underneath trees, so that might be harder. And sometimes they're single stacks, and sometimes they're 2 or 3 high. It depends on the size of the tractor that the farmer has, and it also depends on the size of the farm as to whether they use square bales or round bales. So there's a lot of variables there. That doesn't necessarily lend itself to automation, but you would certainly. It also presumes that they store the round bales on the hayfield that they actually cut from them. So I suppose there's there's multiple variables in that, but you could certainly see round bales, I think, from the LIDAR if in fact they were out in the open. So
yeah, and I'll add, Mike, that I think in a lot of these cases, don't just focus on LIDAR. Think about LIDAR, the leaf-off orthos that are full band now, and the leaf-off imagery. And so you've got 3 data points there, all which are different imaging modalities, which can help you tell a lot about that area.
Great. Okay, the last question is, what type of floodplain/hazard mapping is currently going on at the state or federal level? That is ultimately FEMA's domain. I used to work much more so with the digital flood insurance rate map stuff for Washington County. That was the last time I had my finger in that. So I don't.
And Mike,
yeah.
Mike, there's a huge project going on because of the I believe it was 2010 Lake Champlain flooding, and I know there's studies in Waterbury, and I think they'll be looking with all this new data coming in. I think there's going to be a lot going on with that, and the USGS Water Science Centers are involved with that. I'm not sure about the New York side, but I think I know the shoreline will definitely be flood mapped.
From that, was it the March or April, we had those high winds and the ice jams being pushed up and over the Lake
I believe it was May when they had the.
Was it May?
It was winter.
Late April, early May.
Somewhere in there was in the spring.
Was
and,
there? I'm sorry.
There was a lot more damage in Quebec than there was, and I know the Lake Champlain people are on. They could probably specify better, but there's a lot going on because of that flooding.
Are you aware of any FEMA-related website that shows the status of kind of where they're planning to do those updated digital flood insurance rate maps, or?
I don't. I mean, I see where they request LIDAR, and other than that, I'm kind of out of the picture on it.
So we can assume it's going to follow at some point once they have the data. Then it's really just about doing it, not that they no longer need the data. So, with 2/3 of the state covered, hopefully we'll get the rest. I know Windham County is just begging for LIDAR so that they can update their flood insurance rate maps, as well as Windsor and South.
Can I throw in something that Jonathan just tried to add something to the previous question, and for some reason we can't unmute him. But he said, I believe this is in reference to the tilled soil hayfields question, and unfortunately the person who asked it I think left, but we'll make sure she gets this answer. He said one of the products, and I'm not sure the products of what he's talking about, but one of the products will be an intensity image that could provide this detail on tilled versus grass. So he wanted to comment on the intensity image aspect of the data.
Yeah, Leslie, can you hear me?
Yes, now we can hear you. Yay.
Good, I'm unmuted. And this may not be a product that you're working on through VCGI, but one of the data components of the LAS file that they're actually collecting from the LIDAR sensor is the intensity of the pulse on the return. So you can derive sort of what the surface looks like based on its intensity. Is it a hard reflective surface, or is it something that's actually absorbing a lot of that pulse? So if you have a grass surface, it's going to be absorbing a bit of that light, whereas a dirt surface it may actually be a hard surface and may be reflecting more of it. So you may be able to pull some of that out of the intensity image, but you've got to go back through and process the LAS file to create that intensity image. And I may defer to Jarlath for all the nuances of that step to make that happen, but I think that's just a little bit more information out of the LAS file so you could derive.
Yeah, that's a good point, Jonathan. That's something if people are interested as we work with VCGI on creating surfaces from this, if the intensity images are valuable, we can create those. Intensity can be tricky to work with because it doesn't get color balance like an orthophoto, so there can be a lot of variation. And it's also gathered under leaf-off conditions, so things, of course, represent the condition at the time of acquisition, not what might be happening when you're desired for it. But yeah, if people are interested in that, please follow up with me.
Sounds like a good potential thesis, Jarlath, for some All right. I don't know if there was another question about whether you can add these imagery services to ArcMap, but that's, yeah, absolutely true. And you can do that by going to our website where these services are and just clicking on it, and it gives you the option as ArcMap. And if you say that, say yes. If you have an ArcMap session open, it'll go to that ArcMap session. If you don't, it'll open ArcMap, I don't know which one I just added it to, but here, right here. See, so I popped it right in.
And I wanted to just point out that we will, I assume we will eventually add the link to these services on our regular web imagery services page as well that you showed earlier, yeah.
Right, this one, yeah, how to. This details, you can add it to ArcMap in two ways. You can just click on it and it'll go to the open ArcMap session or open ArcMap session for you. Or you can come down here and, you know, add GIS server, add this, although it's maps dev. If you look at the link, it's maps dev, right? Because it's a prototype, so it's under development. But if you added this URL, insert here, and then follow the rest of these directions, bang, it'll work that way too.
But we'll actually add, this is actually maybe a question for you, Mike, the actual list of services that's on the other page in this section, the list of, no, on that same page, the web services page. No, on the website, web services page.
This one?
Yeah, but the list of services that's in there, not on this section.
Yeah, it's under here.
Web services, yeah. So I assume, are we going to add this prototype to the list of services here, the imagery services?
No.
No? Even with a big red word that says prototype?
I'll have to talk to Steve about that. That's,
Okay.
That's his domain.
So we'll
I mean, it's out there. If people know where the path is, they can access it. So yeah, good point. We'll have to think about how to deal with that. I could forward I can maybe perhaps just put the link out on VGISL, and so it's out there. But we'll come up with a way to address that. I don't have an answer for you right now.
Okay.
And I should have, but sort of thought of it ahead of time. But I was just going to show it here. So yeah, but I'll make it more available somehow.
Okay.
All right.
Thank you, everybody, for participating, and especially our presenters, Jarlath, Jonathan, Lynn, Mike. I feel like that was an information-packed webinar, so appreciate all of you doing this. And
Folks, thanks a lot.
thank you. Everybody have a good day.
You too.
Bye-bye.
Thank you, Mike.
You bet.
Bye, Lynn.
You too.
Bye, Charlie.
Thanks for joining in.